Welcome to solverfy.
This is the answer to Chapter 20, problem number 17 from the Smith Organic Chemistry textbook. This problem tells us to review the oxidation reactions using chromium-6 reagents in section 12.12. And then we're asked to draw the product formed when compound B, which I've redrawn at the top of the screen, is treated with each reagent. And so basically, we need to remember our chromium oxidations. And so for A, we're just treating molecule B with sodium borohydride in methanol. And so that's going to be a reduction. And so we have two alcohols in this molecule already. They will be unaffected. And so basically all that's going to happen here is that our aldehyde at the other end of the molecule, sort of the right end of the molecule, is going to be reduced to an alcohol. Okay, so that's A. So for B, lithium aluminum hydride, it's going to do exactly the same thing. Remember, these are reducing agents, and so since we already have two alcohols in the molecule, they can't really be reduced any further by these reagents. And so it's only the aldehyde that's going to be affected here. Okay, so there we go. A and B are identical answers. Okay, so for C, this is our first oxidation here. And we're using PCC, pyridinium chlorochromate, which, again, if you don't remember what that does, you should have reviewed it from section 12.12. And so our aldehyde is going to be unaffected by this. And hopefully you remember that's the utility of PCC. Other chromium-6 reagents would oxidize the aldehyde to a carboxylic acid, but PCC will leave it as an aldehyde. However, the two alcohols that we have in this molecule are going to be oxidized up to a ketone and an aldehyde. So the primary alcohol is going to become the aldehyde here on the left, and then to the right of the ring, that secondary alcohol will become a ketone. Okay, so then for D, we have silver oxide and ammonium. And this is going to oxidize our aldehyde to a carboxylic acid. So our product here, the aldehyde will have become a carboxylic acid. So it's not going to affect our alcohols at all. So there they are, still intact. And then the aldehyde here has become a carboxylic acid. Okay, and then lastly for E, rather than put it on a page by itself, I just put it up here to the top right. So E is going to be chromium trioxide, sulfuric acid, and water. So Jones conditions. And so this is a very, very strong oxidant. And so this is going to oxidize everything. So aldehyde here. Our secondary alcohol here is now a ketone. And our aldehyde in the starting material is going to become a carboxylic acid. So this chromium trioxide is a very, very strong oxidant. And so we get oxidation at all three of the possible positions in this molecule. So there we go. Let me move it down just to make sure it's visible. Okay. And so that's the answer here. And to get these answers, again, you need to know what each of these reagents does. And as the problem says, if you forget what chromium reagents do, it's in Chapter 12, Section 12. And that's the answer to Chapter 20, problem number 17.